Okay, so for this video, we are going to discuss the May June 2021 series paper 3-2. All right, first question, okay, we are having this, the inequality with modulus on both sides. Generally, when we are having the modulus function on both sides of inequality, the method that I'm going to use to solve it is I'm going to square both sides. All right, so when I want to square both sides, so 2x minus 1 square, it is smaller than, don't forget to square the 3 as well. All right, and then x plus 1 squared. Okay, all right, so you can just expand all the brackets or all the square and try to rephrase your inequality here. All right, and eventually you will get this inequality. So 5x squared plus 22x plus 8, which is greater than 0. So you have to try to get the critical value for the x. So that means you try to solve for the value of the x. And from here, I think you able to get two values here. You can factorize it and you'll get two values here where the x can be equals to -4 and the other value of x can be 2/5. All right, so once you get these two values, then you can use any method to solve the inequality for this question because we are having quadratic inequality here. So this is actually a quadratic inequality, right? Okay, therefore I'm using the number line to solve it. I'm having -2/5 and also the -4. Then I will have the number line both to the right hand side. Okay, then plus, positive, positive, negative, negative. And for this one, I'm having negative, negative, which is positive. All right. For this question, they are asking for greater than 0. So greater than 0 means they are looking for the positive answer. Right, so your equation or expression, right, will become positive at this part now. All right, so which means that when your x is smaller than -4, then this expression is positive. And also x is greater than -2/5, then the expression that we have here will be positive as well. So this will be our answer for question number 1. Okay, so for question number 2. Question number 2, they want you to shade the region where the points represent complex number z satisfying two inequalities here. This is the first inequality and this is the second inequality. All right, so before I want to sketch an inequality, I will want to rephrase it into the pattern that I want. So that means z minus a complex number and it is smaller equals to 1. So the complex number here, if you want to take, you have to make sure that this is a negative value, right? Okay, so the complex number inside, it should be a -1, then plus I. So that when you try to when you try to multiply the negative sign back into the bracket, you will get back the original inequality. Okay, so I will rephrase it into this pattern before I want to sketch, okay, the locus or loci. Okay, then for the second part, I'm having argument z minus 1. So again, I want to rephrase it become z minus a complex number and it is smaller equals to 3/4 pi. Okay, so what will be the complex number here? If you want to get back the original inequality as what they show you, then generally we should put it as 1, then plus 0i. Okay, so usually I will rephrase it like this first because I start sketching the locus. All right, then now for this part, if you look at the pattern, left hand side is a modulus sign and then right hand side is a number. So generally this is a circle. The locus is a circle actually, or the z is the circle. Okay, so for the circle part here, this is actually the center of the circle and this represents the radius. All right. Okay, so -1 and 1 is the circle, is the center of the circle, and 1 will be the radius. Therefore, you can start sketching it. All right, so in the exam, if possible, try to draw your graph as nice as possible, as it might affect your answer if let's say you didn't draw it properly. All right, so usually I will use the ruler or maybe I will use a ruler to measure the ratio and everything so that to make sure that the graph that I draw will be as accurate as possible. All right. Okay, so I'm having -1 here, maybe then this is -2. Okay, so the center is -1 and 1. So -1 and 1, this is the center of the circle. Therefore, the radius is 1, right? So it means the circle will pass through this point, this point, this point, and this point. So I'm trying to sketch out a circle. All right. So my circle will look something like this. Okay, so this is actually the z lah. Okay, and then because for the first inequality here, they are asking for smaller equals to 1. So smaller equals to 1, that means that all the area inside the circle will be shaded for this particular inequality. Okay, so you need to remember that for this inequality, we shade the whole circle. Okay, all the area inside the circle, because any point that located inside this circle, all right, or on the line of the circle, okay, it means that it is smaller or equals to 1. The distance from z, okay, the locus from the center is smaller or equals to 1. Okay, so this is our first inequality. And for the second inequality, first of all, you are looking at the point here, which is 1 plus 0i. So 1 plus 0i means that it is at this point. Okay, and then to sketch the argument, on the right hand side of this point, you need to try to measure 3 pi over 4 radian. So 3 pi over 4 radian, generally we need to measure it, or you can assume that it is 135 degrees. Okay, from the positive x-axis on the right hand side of the 1 and 0. Okay, and therefore you know that my line should go to this side lah. All right, and you need to apply some small knowledge here, where you should know that the complementary angle for 135 is 45. So here is 45. So when you're having a 45 here, that means that if let's say your line go through, okay, go through to this direction, okay, the triangle that they form here should have the same ratio for x and y axis. That means if let's say x is moving 1 unit, then y is moving for 1 unit as well. All right, or the gradient is either +1 or -1. Okay, so by applying some small knowledge that you learned before, okay, from here I will know that my line will pass through the 1, so that it form a triangle here, which is 1 and 1. The 1 unit for x-axis and also the 1 unit for the y-axis. Okay, so my line will pass through here, and it will pass through here also. Okay, then by using a ruler, you can try to sketch it. Okay, so this particular line is my second inequality. Okay, and then if you want, you can actually try to tell them that this is 3 pi over 4. And when they say, ask you to shade the region for smaller equals to 3 pi over 4, right? So you should shade actually this whole region here. All right, okay, and now they want us to shade the region for both inequality. So you have to try to combine both inequality just now, okay, and try to figure out where is the area that you shaded for both inequality. Where is the overlapping of the area that you shade for the two inequality just now? Okay, so if you aware of it, this is the part. This small little part here is actually the intersection of the shaded area for two inequality, where this is also our final answer. All right. Okay, so this is an Argand diagram. Therefore, the label will be, this is real, the real part of Z, and this is the imaginary part of Z. Okay. Okay, so question number 3. Okay, they give you an equation involve x, y, and also there's a constant a. And then they want to explain why the graph of y against the ln x is a straight line, and state the exact value of the gradient of the line. Okay, so they are asking why the graph of y against ln x is a straight line. Okay, so generally you should know that this is your y-axis when they sketch the graph, and your x-axis is actually ln x. Okay, so to show that it is a straight line, so you have to try to express your original equation to make it become the pattern of y equals to mx plus c, because for a straight line, you should have the pattern which is y equals to mx plus c. Okay, all right, so we will start from our original question here. X is equals to a and then 3 minus 3 power minus y, or negative y. Okay, so from here you see that they are having ln x. So what I want to do is I want to separate everything out. So I take ln for both sides. So I'm having ln x, then ln a, multiply with 3 negative y, 3 power negative y. Okay, so by applying all the properties for ln before, ln a multiplied with 3 power negative y, you can rewrite it become ln a plus ln 3 power negative y. Okay, and after that, you should have ln a minus y ln 3. So that means the y, the negative y, you can put in front for the power with the ln in front, okay, or with the log in front. Okay, then after that, you want to rephrase your answer into this y equals to mx plus c pattern. Okay, so I will move the y to right hand side, to the left hand side, and then I'm having negative ln x plus ln a, and I'm having y equals to negative 1 over ln 3 multiply with ln x plus ln a divided with ln 3. Okay, so I'm having this equation, and I want to compare it with the straight line equation now. So if you try to compare, you are having y equals to mx plus c. So you should know that y means the y-axis, the x here means the x-axis, which fulfill what they want us to prove, right? Okay, they are telling you that when you sketch a graph for y for y-axis and ln x for the x-axis, you'll get a straight line. So from here you can see that your y-axis is y, your x-axis is ln x. Therefore, this equation actually completely matching, okay, match the equation y equals to mx plus c. All right, okay, so this is how you prove lah. So if you want, then you can make a simple conclusion here. Okay, the graph of y against ln x can be expressed as y equals to mx plus c, which is actually the equation. Okay, so which is the standard form or standard equation of a linear line. Okay, all right, so this is how I prove it. I try to compare it with the standard form of the linear equation, which is y equals to mx plus c. So from here, I know that it is actually a straight line. Okay, and after that, they want you to state the exact value of the gradient of the line. So I think it is quite straightforward, because if you compare it, the gradient, you know, is m, right? Okay, the standard form for gradient is m. So if you compare it with the value that we get in our equation, so you see that it is matching with negative 1 over ln 3. Therefore, you can just tell them that your gradient is equals to negative 1 over ln 3. Okay, so this is how we actually prove it. Okay, then now we go to part number 2. Okay, so for part number B, they say it is given that the line intersect the y-axis, okay, intersect the y-axis at the point where y equals to 1.3. Okay, so when they intersect the y-axis means what? Means the value for x-axis okay, is equals to 0. Clear or not? All right, okay, so they want you to calculate the value of a, giving your answer correct to 2 decimal places. Okay, so by using the information, you know that when the x-axis is equals to 0 means that when ln x equals to 0. Okay, because now our x-axis is ln x. All right, so when ln x is equals to 0, the y-intercept that you get is actually 1.3. So by using this information, I want to find out the a. Okay, so my original equation is y equals to negative 1 over ln 3 ln x, then plus ln a divided by ln 3, right? Okay, so as what I mentioned just now, the y now is 1 over 3, 1.3. The ln x is equals to 0. Okay, so the whole thing here will be 0. Okay, then left ln a divided by ln 3. Okay, so ln a will be equals to 1.3 multiplied with ln 3, and the a will be e power 1.3 ln 3. Okay, and then you try to rephrase your answer into 2 decimal places, you should get the answer, which is 4.17 for the value of a. Okay, so question number 4. They want you to do the integration by using the rules for integration by parts. Find the exact value, okay, for this integration. All right, so they already tell you very clearly that they want you to use the integration by part. Okay, so generally you need to decide which one is your u and then which one is your integrate dv. All right, so we are having the root liate, right? Okay, so going upwards it will be the u, going downwards it will be the dv lah. Okay, right, so let's have a look for our function here. So generally in this function, you see only the tangent inverse half x, but you can assume that in front got another function which is a 1. Okay, 1 multiplied with tangent inverse half x. All right, so for this one, very obvious, it is the inverse trigo, so it belongs to I. Okay, and then for the 1 here, it belongs to algebra, which is the A. Okay, so you can see that the I here, the group I is higher than A, right? So that means the I will be the U and the A will be the dV. Okay, so since you already decide that U is the inverse function, U is the inverse trigo, so you let U equals to tangent inverse half x. Okay, where your integration of dV will be equals to the 1. So integrate 1 dx. Okay, so this is how we start the integration by part lah. You have to decide the u and dv correctly first. Okay, so for the u part here, you need to do the differentiation. So I'm going to do the du dx, find out the du dx. So to find the du dx, what you have here is differentiate the tangent inverse. You are going to have 1 plus the angle square, and then multiply with the differentiation in the angle. You are having half here. Okay, so if you try to simplify and rephrase everything, all right, then we are having 1 over 2 divided by 1 plus 1 over 4 square x square, and try to simplify everything, multiply everything by 4, okay, on top and bottom of the numerator and denominator, and you should have 2 divided by 4 plus x squared. So this is what I have for my du dx. Okay, so for this part, you are having integration. So integrate 1 dv, you get dv, you get a v. Integrate 1 dx, you get the x. So this is very simple. All right, okay, then now we try to apply the formula. So to apply the formula, we are having uv minus v du. Okay, where the original equation is u dv equals to uv minus dvu. So we are going to apply this here, v du, all right? Okay, so let us start now. Maybe I will put my solution here. Okay, my original question is this. So I'm having tangent inverse half x dx. All right, so it is equals to uv. Okay, so you can see the uv here. So what is my u? U is originally tangent inverse half x. So you just put in tangent inverse half x multiply with v. So what is your v? V is this one, which is the x. And because this is the definite integral, right? So you have to put in the limit for the first part here, the uv, then minus integration of the same limit of v du. So again, this is your v, which is the x, and then how to get the du. So from here you can see that du dx is equals to this one, and therefore the du will be 2 over 4 plus x squared dx. All right, I hope that you can see it here. This is du over dx, right? So du over dx is this whole fraction here. So when you move the dx to the right hand side, your du is equals to this whole part. Okay, 2 over 4 plus x squared dx. All right, okay, then next step. So for the next step, you can substitute the value in. Okay, when you substitute 2 inside the bracket, inside the x here, so you will have 2, okay, and then tangent inverse 2 over 2 is a 1. So tangent inverse 1, you will have pi over 4, which is 45 degree lah. Okay, but for integration, everything you have to write it in radian form. Okay, then minus. All right, so for this one, if you look at the pattern in detail, you are having 2x divided by 4 plus x squared dx. Okay, so if you try to identify the pattern of this fraction, right, you will realize that it belongs to f prime x over fx pattern. So when you want to integrate, you just have ln fx. Okay, right, so again, I continue from this part. So for this one, I can simplify it, become pi over 2. Okay, then minus. When I integrate this bracket, I'm having ln, then 4 plus x squared. Then put in the limit 2 and 0. Okay, so from here, you can slowly substitute in the values. So 2 squared is a 4, 4 plus 4 is 8, minus 0. When you put it in, you'll get ln 4. Okay, then if you further simplify, you're having pi over 2 minus ln 8 divided by 4. Okay, because ln 8 minus ln 4 means ln A minus ln B. So it will become ln A divided by B. So I'm having 8 divided by 4. Okay, so eventually you try to further simplify again, and you are having pi over 2 minus ln 2. So I think this is the most simplified answer that I can get for the exact form of the answer. All right, so question number 5, asking for the square root of u. Okay, and then you have to give the answer in the form of a plus bi, where a and b are the real and exact. Okay, so that means you have to keep your answer in the exact form. All right, so square root of a complex number, you just need to, you know that the square root of the complex number, the answer will be also a complex number, right? Okay, so generally how we start is we will take square root of the u. So the square root of u means square root of 10 minus 4 square root 6i. You will get the complex number as well as your answer, which is a plus bi. Okay, so I will bring the square root over where you need to square the a plus bi. Okay, then you expand everything on the right hand side. So a square, you get a square, so plus 2abi. Okay, then bi square, you have b square, I square. So the I square is negative 1, therefore you have negative b square. Okay, so I try to compare the real part with the real part. So the real part for this complex number will be a square plus minus b square. Then the imaginary part will be 2abi. Okay, so I hope that you can see very clearly that I want to compare. This is the real part, the real number. I will compare it with this. And the imaginary part is negative 4 square root 6. I will compare it with 2ab. So from here, you actually form two equations. So a square minus b square. Okay, so maybe I write like this. A square minus b square is equals to 10. And this will be your first equation. And after that, 2ab, it is equals to negative 4 sub 6 or square root 6. then I will maybe let b. All right, so you will see from here that b is equals to negative 2 square root 6 over a, and I will make this as the second equation. Okay, so I think the concept is quite simple, where you need to just solve the simultaneous equation to get the a and b. Okay, all right, so I will start sub 2 into equation 1. All right, so I'm having a square minus b square equals to 10. Okay, and then I'll continue on this part here. All right, so I will have a square minus, then 4 times 6, you will have 24. Then over a square, I bring the 10 over, become negative 10, and it is equals to 0. All right, so I want to make the a square disappear as a denominator, so I multiply the whole equation with a square. So if I rephrase it again, I will have this quadratic form equation in a squared. All right, okay, so since you're having the quadratic form equation, you can try to factorize it. And then from here, you will realize that a equals to 12, and also a squared equals to negative 2. And since they tells you that a should be a real number, right? So you should actually ignore this part of the answer of this part, because when you take square root negative 2, the a will not be a real number. All right, so I'll ignore this part here. Okay, I'll continue with the first one, this part. Okay, so I try to take square root over, so I will have plus minus square root 12. So if you want, you can further rephrase it as plus minus 2 square root 3. Okay, so your a has two values, so you need to try to find a and b now, the b now. Okay, so when a equals to positive 2 square root 3, what is the value of b? So you can substitute it back into the second equation here. All right, so when you substitute 2 over square root 3, okay, then your b is actually negative square root 2. Or you can write it out like if you want. Okay, so you substitute it into this second equation, divided by 2 square root 3. So square root 6 divided by square root 3, you have having square root 2, so minus. Okay, then when a is equals to negative 2 square root 3, and what is the value of b that you get? So you will have positive square root 2. Okay, so the answer will be the square root of u, square root of u will be equals to 2 sub 3 minus sub 2i, or negative 2 square root 3 plus square root 2i. So these are the two square roots, okay, for the u in the exact formula. Okay. Okay, so question number 6. All right, they want you to prove that this equals to tangent theta on the right. Okay, so again, I will start from left hand side, because of the left hand side have the double angle. All right, okay, so I'm having cosecant 2 theta minus cotangent 2 theta, which is equals to, okay, so on the right, they have only the single angle. Okay, so left has double angle. All right, so that means you can maybe try to expand it. But before I expand it, then I will want to combine these two terms, become one term. Because on the right hand side, you have only one terms on the right, correct or not? So we need to combine it, become one term first. So how can we combine it, become one term? Because if you try to rephrase it, you have cosecant is 1 over sine. All right, then cotangent is cos over sine. So you realize that the denominator are actually the same, and therefore you can combine that into one term very easily. Okay, and then the next step is I will want to expand the double angle, okay, so that I get something in single angle, all right, in the theta. All right, so for tangent theta, it should be sine over cos. Okay, so that means I should have something related to sine on top, then cos at the bottom. Okay, so when I try to replace cos 2 theta, I'm going to replace the cos 2 theta with 1 minus 2 sine square theta. Okay, there are three formula for cos 2 theta, right? Okay, so for me, I'm going to use this only because I know that I want to keep the sine theta on top. All right, okay, so I will substitute 1 minus 2 sine square theta, then divided by, okay, so for sine 2 theta, the double angle formula is very straightforward. There's only one, which is 2 sine theta cos theta. Okay, so substitute it straight away into your equation or into your expression. Okay, so if you try to simplify further, then this is what you will get. Okay, and I think the answer is very obvious. 2 and 2 can be simplified off. Then the square and the sine theta can be simplified off also. And therefore, you're having sine theta divided by cos theta. And eventually, you get what they want you to prove. It is equals to tangent. All right, so this is what we have for the first part. Okay, part A. Then now we continue to part number B. So for part B, they want you to complete the integration, the definite integral, okay, for the equation here. All right, so maybe if you want, you can double check. They want you to integrate the equation on the left hand side. Okay, then generally it's like that. For part A, when they ask you to prove, right, you have to use the result most of the time in part B. Okay, so I'm going to apply this also in part B. Okay, so first of all, I'm having pi over 3 divided pi over 3 for the upper limit and pi over 4 for the lower limit, okay, of cosecant 2 theta minus cotangent 2 theta. Okay, then I know that this expression on the left is equals to tangent theta generally. Okay, so they want us to integrate tangent theta. Right, so for your information, right, you should aware that tangent theta can be written as sine theta over cos theta. Sine theta over cos theta. Okay, if you try to differentiate cos theta, then you should have a negative sine theta on top. Okay, so if let's say you put a negative sine theta on top, then that means you need to put a negative outside also, so that this whole equation, the whole expression will become the f prime x and the fx and f prime x on top. Okay, I want to get the pattern f prime x over fx. Okay, but I know that I'm lack of a negative. I want to have a negative sign in front of sine theta, so I put in the negative sign beside the sine theta and also outside so that it balances up. Okay, but in this bracket, I'm having the f prime x over fx pattern. Okay, so this is how I continue with my step here. Okay, so I'm having negative and then negative sine theta divided by cos theta because I know that this bracket itself will be the f prime x over fx pattern, and it will be easier for me to do the integration later. So negative in front, I just keep it. Okay, integrate this bracket, you will get ln cos theta. And then I'm having pi over 3 and also pi over 4. Okay, so you substitute the limit inside. So you're having cos pi over 3 minus ln, then cos pi over 4. Okay, and then you try to retrieve the value for cos pi over 3 and pi over 4. So for cos pi over 3, it will be half. Okay, cos pi over 4, you will have 1 over square root 2. So I will keep everything here in a third formula or the exact form, because the final answer that they want us to show, right, is actually the exact value as well. Okay, so once I get until this step, okay, I try to apply there are many ways for you to simplify it. Okay, so I try to expand everything. Okay, so ln half means ln 1 minus ln 2. Okay, ln 1 over sub 2, I will get ln 1 minus half ln 2. Okay, all right, so from here, you need to try to simplify a little bit more. So ln 1 is equals to 0. This ln 1 is also equals to 0. Okay, then if you put the negative inside all the value here, you are having ln 2. Okay, then minus half ln 2. And eventually, you take the ln 2 as apple. So you assume that this ln 2 is apple. This ln 2 is also the apple. And you're having 1 apple minus half apple. So eventually, you are having half apples here, which is half ln 2. Okay, so this is how we prove to get the answer that they want us to show. Okay, so question number 7. All right, so they give you a curve such that the gradient at the general point. So again, when you see the word gradient at a general point for a curve, right? So this gradient has a symbol of dy dx. So this is something that you need to know in advance. All right, so this is dy dx, and then with coordinates xy is proportional. So proportional means that you have a k in front of this expression. Okay, so for this sentence itself, generally when you try to translate into a symbol form, it will be dy dx, all right, is equals to k. So that means it is proportional. So you have a k here, and then proportional to the expression y over square root x plus 1. All right, so this is how I get my differential equation from the first sentence given in the question. All right, okay, then next, the curve passes through the point with this coordinate. So these two coordinates, we will use it later after the integration for us to find all the constant value like k or maybe the c that appear later after the integration. Right, so by setting up and solving the differential equation, find the equation of the curve expressing y in terms of x. So your final answer should be expressed in terms y in terms of x. Okay, so as what I mentioned just now, from the first sentence in this question, I can set up this differential equation already. Okay, then the next step is you have to move all the y variable to one side, all the x variable to one side. So if I try to move all the y variable to one side, I will have 1 over y dy, and it is equals to 1 over square root x plus 1 dx. And then the k, usually the constant k, I will put it together on with the x on the right hand side. Okay, then once you separate them clearly, so you can see that the left hand side, everything about the y, right hand side will be everything about the x. So you can put the integration sign. Okay, so once you separate them clearly, then you can integrate this whole equation okay, separately on the left and also the right hand side. So when you want to integrate 1 over y, you get ln y. Okay, and it is equals to k is a constant, therefore you just copy. And then originally you're having power negative half, right? When you're having square root x plus 1 means power half, and it is at the denominator, so negative half. So power plus 1 become positive half divided by the new power, and then plus c. Okay, so this is my integration, the integration that I can see for now. Then before I will find out the value for k and c, usually I will prefer to rephrase my expression or equation in a better way. So the 1 over 2 at the denominator, I will make it become 2, so 2k, and then x plus 1 power half, then plus c. Okay, so you can see that in my general solution here, I'm having the K and also I'm having the C. So I need 2 points or maybe 2 extra information to get the value for K and also the value of C. So first of all, I'm looking at this first information here. The coordinates here means that x equals to 0 and then the y equals to 1, right? Okay, so you can write it in this way. So at the coordinate 0 and 1, so you will have your equation as ln 1 equals to 2k plus c. So what's the value for ln 1? Ln 1 is 0, right? So you will have c equals to negative 2k. And this is the first equation that I can get. All right, then at the second information, okay, so at the second information, I'm having 3 and e power 1. Okay, so ln e power 1 equals to, substitute the x equals to 3. So 3 plus 1 is a 4. Square root 4 is a 2. So you're having 4k, right? So 4k plus c. Okay, then if you continue to simplify it, then suppose you should have 1. So ln e power 1 is a 1. So 1 equals to 4k plus c. And this is my second equation. Okay, so you need to solve simultaneous equation to get the value for k and also the c. All right, so you can substitute 1 into equation number 2. All right, so I'm having 1 equals to 4k minus 2k. So from here, very obvious, you can see that the value of k is 1 over 2. And therefore, when the k is equals to 1 over 2, very easily, you can get also the value of c, which is actually a negative 1. Okay? All right, so they want you to express your answer y in terms of x. So you substitute all the value for k and c into your general solution to get the particular solution. So k is half, right? So you're having x plus 1 power half. And then your c is negative 1. Therefore, you're having a negative 1 here. Okay, then now you want to bring the ln over. The base will become base e. So e power. So the square root of x plus 1. If you the power half, you can write as square root of x plus 1 if you want. If you keep it as a power form, if you want, also no problem. Then minus 1. So this is my final answer, okay, for this differential equation. So you can see that I try to rephrase my answer y in terms of x. Okay, so now it's question number 8. All right, so they give you the equation of a curve, which is y equals to e power negative 5x, then multiply with tangent square x. And then the domain given is from negative 90 degree to positive 90 degree. Right, so what they want us to find is find the x coordinate of the stationary points. So when you see the word stationary point, means that they want you to find either the maximum or minimum. So which means that you need to do the differentiation of dy dx, all right? And you let it equals to 0 to get the stationary points. And they are looking for only the x coordinate. Okay, then they want you to give your answer correct to 3 decimal places where appropriate. Okay, so first of all, we are having the equation y equals to y equals to e power negative 5x. Okay, so to me, this is the first function multiplied with the second function, which is the tangent square x. Okay, so you're having the product of two functions here. Therefore, when you want to do the differentiation, you have to apply product rule. Okay, so for the product rule is to get the dy dx. Okay, so you can differentiate the first bracket first, the first function. So the first function, when you differentiate, you have negative 5 and then e power e 5x. Then you copy the second function, which is tangent square x. Right, then plus, you do the other way around. Now you copy the first bracket, first function, and you try to differentiate the second function. So the second function here is tangent square x. Okay, so the square. So tangent square x means that you want to differentiate tangent x square. So to differentiate this, what you need to do here is you pull the power in front. So you have 2, copy back the bracket tangent x, then you differentiate the tangent x, where you will get a secant square x. All right, so this is how we do the differentiation by using the product rule. And after that, I will want to try to simplify it. So from here, if I have a look in detail, right, I'm actually having e power negative 5x for both terms, and also the tangent x for both terms. So I will want to factorize them out. And after that, what will I have is the remaining terms that I have is 2 secant square x minus 5 tangent x. Okay, so when you try to simplify, I try to factorize out the e power negative 5x and also the tangent x. Then from here, you can see that this is the remaining terms that I have. Okay, so I will let dy dx equals to 0 when I want to find out the stationary points of the curve. Okay, so first you are having 3 parts of the function. Okay, this is the first part, this is the second part, and this is the third one. So we will have e power negative 5x equals to 0. Okay, secondly, we are having tangent x, which is equals to 0. And also 2 secant square x minus 5 tangent x, and it is equals to 0. Alright, so when you're trying to solve this one by taking ln both sides to get the value of x, you will see that you'll get a math error. Therefore, this one you cannot get any solution from here, so we ignore this solution for this part. Alright, then for tangent x equals to 0, okay, so you take tangent inverse 0, and the x value here you will get a 0. Okay, so this might be one of our solution. And after that, for the third part here, we need to try, okay, to solve it. All right, so we are having secant square, and we are having tangent x. All right, so there are many ways for you to solve this side if you want. Okay, so first method is maybe you can consider, right? Okay, for secant square x, is there any identity that is related to secant square or secant x with tangent? All right, so I think we learned one identity before, right? Which is sine square x plus cos square x, it is equals to 1. And if you try to divide the whole equation, okay, with cos square, and then you'll get a new identity, which is actually it's a similar identity, all right? So sine square divided by cos square, you have tangent square. Cos square divided by cos square, you have 1. And then 1 divided by cos square, you will have secant square. So I think maybe you can use this one. So which means secant square itself is equals to tangent square plus 1. All right, so I'm having 2. And then tangent square x plus 1 minus 5 tangent x, and it is equals to 0. So if you can, you try to rephrase it again. Okay, then from here, you will see that actually you get a quadratic form equation in terms of tangent x. Okay, so now you can try to solve it. All right, so you can try to solve it by using the quadratic formula, or maybe by using factorization if you can factorize it. All right, so if I'm not mistaken, okay, when you try to get the answer for this part, the value for tangent, you have 2 values, right? So the first value for tangent will be 2. Okay, another value for tangent will be half, because you can factorize it actually. All right, factorize into 2 brackets, and then you get tangent x equals to 2, and also tangent x equals to half. All right, so you need to try to solve these 2 equations. But again, you need to ensure that the answer that you get is within the domain given. All right, okay, so now for the domain given here, they are from negative. Okay, so from here to here, it will be from 0 to negative pi over 2. And then from here to here, it will be from 0 to pi over 2. So to get the answer for this quadrant, the first quadrant, the answer is theta, which is the basic angle. And then to get the answer for this quadrant, it will be negative theta, which is the theta here will be the basic angle as well. All right, and after that, for this quadrant, all identity of all the trigo terms will be positive, right? Sine, cos, tangent will be positive. And then for this one, the fourth quadrant here, only cos will be positive. Okay, all right, so now let us continue with our solution here. So to get the x, you need to get tangent inverse 2. Okay, so when you get tangent inverse 2, what is the answer that you will get? So you'll get 1.107, which is the basic angle in the first quadrant here. Okay, all right. So in this first quadrant, generally tangent is positive, so this is the answer that I want. Okay, but if you look at the fourth quadrant, you will realize that tangent is not a positive value in this quadrant. Positive value you look at here. Okay, right. So this is not positive. Tangent is not positive in the fourth quadrant. Therefore, I don't want the answer from this quadrant. All right. So x equals to 1.107 will be the answer. Okay, so the other formula will be this one, the other part. Okay, take tangent inverse half. So when you try to get tangent inverse half, all right, so into 3 decimal places, right, the answer that you get should be 0.464. So again, if you look at this value, it is a positive value. So tangent x equals to positive half. That means I also only consider the answer from the first quadrant. So from the fourth quadrant here, in the opposite direction, this is not something that I want. Okay, so that means this is the answer that I want. This is also the answer that I want. So in short, right, maybe you can rewrite all the answer first. So you're having 3 answers here. The first one is this, x equals to 0. The second one is x equals to 0.464. And the third one will be x equals to 1.107. So maybe if you can, you try to rewrite your answer again. All right, so the answer will be x equals to 0, x equals to 0.464, and also x equals to 1.107. So there are 3 answers for this part, 3 values x for this part. So all these are actually the stationary point, the x coordinate for stationary points for the equation given above. Okay, so for question number 9, they give you a function, a rational function, all right, and then they want you to express this function in partial fractions. Okay, so we are going to separate it into the smaller partial fractions here. Okay, so first of all, what I'm going to check is the degree of numerator. So the degree of numerator is equals to, the highest power is 2, and then for the denominator, the degree is 3. So which means this is actually a proper fractions. Right, so for proper fractions, what you can do is you can straight away separate into the partial fractions. Right, okay, so let's start. We are having 14 minus 3x plus 2x squared over 2 plus x with this. Okay, so the first one is actually the linear factor. So on top, we are having the constant a. And then for the second partial fraction, the denominator, denominator is actually a quadratic factor, right? Because you're having the x squared here, it is a quadratic factor. So for quadratic factor, the numerator should be bx plus c. That means the numerator starts from 1 degree lower. Okay, so which is bx plus c. Okay, so for the whole terms, for this whole equation here, I'm trying to multiply it with the original denominator. So when I multiply with the original denominator for the whole equation, so I will have this equation, which is something like this. Okay. All right, so now we want to find out the value for A, B, and C. Okay, so I have to eliminate some unwanted unknowns. So as an example, for the first value that I choose, I will focus on this bracket. So if I let x equals -2, this whole bracket will become 0, and the B and C will disappear. Therefore, you can get the value for A. All right, so the first value that I will focus is on this value. I will let x equals to -2. Okay, so when x equals to -2, okay, substitute it into the left-hand side of the equation. You should able to get to 28. Okay, without any careless mistake, you should get a 28. And then -2, substitute into this equation, you're having 4. 4 plus 3 is a 7, so you're having 7a. And then -2, substitute it into this bracket, it will become 0, and the whole terms here disappear. All right, okay, so I will get the value of a very easily. So to get the value of a, you get a 4. All right, then now the second value. So for the second value, I'll focus on this part. the x here, because if I let x equals to 0, then b will disappear. Then only a and c remain, and from here you can get the unknown c, okay, the value for c. Okay, so I will let x equals to 0. When you let x equals to 0 again, the left hand side here you'll get a 14. Okay, then 3a. So substitute the value a, multiply with 3, you get a 12. Then plus c. C is something that you don't know, and then you're having a 2c. Okay, so from here again, if you try to simplify your equation, then your c is actually equals to 1. All right, okay, then now comes the very last unknown b. Okay, so to get the b, you can use any value that you haven't used yet. Okay, so just now you use -2, you use value 0, so you can choose any value that you like. All right, so for me, I will choose a simple value, which is x equals to 1. Okay, so substitute all the x in the equation. Okay, equals to 1. All right, okay, so for x equals to 1, if I substitute into the left hand side, I will have 13 equals to, then you substitute the 1, okay, here. Then 1 plus 3 is a 4. 4 multiplied with 4, you get a 16. Okay, then plus bx, so means b lah. Then c is plus 1, and then 2 plus 1 is a 3. Okay, so from here again, if you simplify it slowly, all right, then eventually you will get the value of b, which is -2. Okay, so for this part, it is actually quite, you already get all the value for a, b, and c, so you can rewrite your equation again. All right, so for this rational function, all right, the final answer for the partial fractions will be 4 over 2 plus x, okay, and then bx plus c. So because my c is the positive value, so I'll put it in front, 1 minus 2x divided by 3 plus x squared. So this is the partial fraction for the function fx. Okay, all right, then now let us continue to the part number 2. Okay, so for part number b, all right, so hence they want you to obtain the function of fx in ascending power of x up to and including the terms in x squared. All right, so generally they want you to do the binomial expansion for this both. Okay, so we're having two terms here generally. This is the first term, okay, and this is the second term. Okay, so maybe I would want to expand them separately, then only combine them together. All right, so for the first term, I'll write in a purple color form, purple color ink. All right, so the first term is 4, and then 2 plus x power -1. And I want to do the binomial expansion for this. Okay, so first of all, you need to ensure that before you apply the binomial theorem formula, you have to ensure that this is a value 1. Okay, the first term in the bracket should be a value 1. Therefore, what I do is that I factorize out the value 2 with followed by the power, the same power, and then in the bracket will become 1 plus x over 2 power -1. So once you ensure that this bracket is start with the first term is a 1, then you can apply the formula for binomial theorem straight away. All right, so for the value in front, you can just straight away simplify it as 4 divided by 2, you get 2. Okay, then now I want to expand this bracket. Okay, so for this bracket, binomial expansion theorem is first term is always a 1. The second term is nx, so the n is your power. X will be the term at the back, right? So this term here. Okay, so this is the x, so your x is actually x over 2. Then plus n minus 1. All right, so n minus 1 means you get a -2 lah. Okay, so -2 divided by 2 factorial, and then the x over 2 squared. Okay, so because they're only asking until the terms in x squared, so you can see that if I look at my expansion here, okay, the x already have a square. So the next term will be x power 3. Therefore, you can actually try to stop here. No need to show the further expansion anymore. All right. Okay, so for this part, if you try to simplify it, you'll have 2, and then 1 minus x over 2, and then plus x squared over 4. Okay, so you have the terms until x power 2 lah, up to x power 2 for this first part, the first term. Okay, then next you go for the second term. So for the second term, you're having 1 minus 2x. This is power 1, right? So you actually no need to do any expansion for this term, but we are going to focus on the denominator, which is 3 plus x squared power negative 1. So again, if I want to apply the binomial theorem, so I need to ensure that this first term here start with 1. Okay, so how to make sure that it is start with 1? So you have to factorize out the 3 with the power, and then inside the bracket you are having 1 plus x squared over 3, then power negative 1. Okay, so for this one, maybe you can slightly rephrase it in a better way. Okay, then now I want to expand this last bracket here by using the binomial theorem again. Alright, so the first term is always the 1. Second term is nx, so n, and then this is my x. Alright, then for the next term, if you try to expand until the next term, for the next term, right, you will see that you're having nx power 2. So this is your x power 2. So eventually you will have x power 4, which is something already exceed what they want, exceed higher than the power that they want. Okay, so for me, for this part, I will only expand until here only. Okay, because here I already have x power 2. The next term, if I expand it, it will become x power 4. Therefore, I'm not interested in getting that, so I will just stop here. Okay, and then again, you can try to simplify it first. Okay, so 1 minus x squared plus 3. All right, so now, for this part, you can further expand it, okay, to get the terms that you want. So as an example, 1 multiply with 1, you will get 1. And then 1 multiply with this, you will get something with x squared, which is also the terms that you want to include in your solution, right? So you include in your step here, which is negative x squared over 3. Then you go for the next term, negative 2x multiply with 1, okay, and you will get negative 2x. And if you check for the next term, negative 2x multiply with this, eventually you will get x power 3, okay, which is also already exceed the power that they want you to include in your solution. So that means I'm not going to further show it out, okay, further to expand it anymore. So this will be my answer here. Okay, then to get the final answer, you just need to add these two terms together, because just now you're having term 1 plus term 2, right? So when you want to do the binomial expansion also, you use the answer for term 1 plus the answer for term 2. Okay, so I'll combine both of them together to get the final answer. So the binomial expansion will be for the final answer. All right, so the binomial expansion, it will be 2 minus x plus x squared over 2, then plus 1 over 3 minus x squared over 9, then minus 2x over 3. Okay, then the rest you can just ignore them, and then you try to rephrase everything. So the constant with constant together, you should get 7 over 3. When you want to get all the term with x power 1 together, you will get negative 5 over 3x. And also the term for x squared will be 7 over 18x squared. Alright, so this is actually how we get the answer for the binomial expansion for these partial fractions. Okay. Okay, so for question number 10, they give you a trapezium ABCD as shown in the figure here, the diagram here, and then AB equals to BC. All right, so AD is equals to BC equals to R, and also AB equals to 2R. So they give all the information. Okay, they explain some extra information, some information about the diagram that they give you here. So the acute angle BAD and ABC are both equal to x radians. So the circular arcs of radius R with center A and B meet at M, the midpoint of AB. So M is actually the midpoint of AB. So for the first part of this question, they are telling you that the sum of the areas. So the sum of the areas of the shaded sector. So the shaded sector, if you want to find the area, I think it is quite straightforward. All right, because all the information are there already. Okay, it's 90% of the area of the trapezium. Okay, and show that x satisfy the equation for this one. Okay, so I think maybe we need to do some preparation for the area of trapezium first. Okay, so how to find the area for trapezium? So the area for trapezium is actually equals to half multiply with the height. So where is the height for this trapezium here? So generally the height will be this one. Okay, I will assume that this is the height. Okay, all right, so this is the height, and then multiply with the sum of the two parallel lines. So the two parallel lines here will be CD and also BA or DCBA or DCAB. Okay, so this one you can write as DC plus AB. The length for DC and also the length for AB. Okay, all right, so if you look at the formula here, actually there are a few important information that you need to have. So you need to know what is the H, what is the height. Okay, you also need to know what is the length for DC. Okay, all right, so to get the DC, actually you should try to link it with AB minus this one, this length, and this length. All right, so if AB minus these two length here, then you'll get the length for DC. Okay, so no matter how, you need to set up a little bit first. Okay, so this is the area of the formula for the area of trapezium, and I want to find out the H now in terms of R and also the X. Okay, so to get the H, generally I'm going to look at this triangle here that I draw. Okay, so if I refer to this right angle triangle, right? Okay, from here, you actually can get that sine x is equals to H over R. R is the hypotenuse. So very easily you will get H equals to R sine X. You want to express all your answer, right? All your info in terms of R and also in terms of X. Okay, so I get the H equals to R sine X already. So this is done. Okay, then AB. AB is actually 2R, which is also in terms of R, also done already. Okay, then now I want to get the DC. Okay, so to get the DC, I need to find out this particular length first. All right, so this particular length, maybe I put it as T. Okay, so to find out the T, again, I can use the same right angle triangle and write it as cos X equals to T divided by R. So the length for T is actually R cos X. All right, and I want to get DC. So DC is like this length. Okay, this length here, this is the DC. So to get the DC, it is actually 2R. That means AB is 2R, right? So AB is 2R minus 2 times of R cos X. Okay, so this is the DC. So DC, I also express it in terms of R and X already. Then I will put everything together. Okay, so how to put everything together here? Okay, so the sum of the area of shaded sector. Okay, so the sum of area for sector, okay, and it is equals to 90% the area of trapezium. So the sum of the sector area, right, it is actually 2. You have 2 sectors, right? So for both sectors, they're having the same formula, the area, which is half r square theta. So the theta is actually the x. And it is equals to 90%. So 90% is 0.9. The area of trapezium. So this is the area of trapezium, and I want to substitute all the information that I get just now. So half, the h is r sine x, and then dc. So dc is 2r minus 2r cos x plus ab. So ab is 2r. Right? Okay, then you try to simplify all the values that you can simplify it first. Okay, so I'm having 0.9, then this is still the half r sine x. Okay, so to simplify this part, I will have actually 4r minus 2r cos x. Okay, then again, I want to further simplify it more. Okay, so now here I can factorize out the 2, okay, and also the r. Right, if I factorize out the 2 and r, I will have 0.9. Okay, then half r sine x, 2r, then 2 minus cos x. Okay, so of course this half and 2 can be simplified. The r and r here can be simplified with r squared on the other side. So eventually, if you rewrite it again, then you can see very clearly that you get the answer that they want you to show. All right, so this is how we actually prove the equation that they want us to get. All right, okay, so this is part A. And then let us continue to part number B. Okay, so for part number B, okay, they want you to verify that the x lies between 0.5 to 0.7. Okay, so again, we will start from this equation here actually. All right, so to start with this equation and proof, right, you need to make it into a function first. So I will actually let the function fx, it is equals to 0.9, then 2 minus cos x sine x, then minus the x. Okay, then I want to substitute the both values inside, so I will substitute the value 0.5 into this function, and after that I will substitute the value 0.7 into this function. Okay, so just a reminder to all of you here, because we are having the trigger in our equation or expression, so when you want to press the calculator, you have to ensure that your calculator is in radian mode. Right? Okay, so when you substitute f is 0.5. Okay, if you didn't do any careless mistake, then you should get negative 0.0157. All right, if you substitute the 0.7 into the function, then you should be able to get 0.0161. From here, very clearly that you can see there's a sign change, okay, between the f0.5 and also f0.7. All right, so you can make a conclusion saying that there is a sign change can be seen between these two value, these two function. Therefore, the value of x lies between 0.5 and 0.7. Okay, so this is how we actually solve the question number 2, part B. All right, okay, then maybe we can go further for part number C. All right, so for part number C, they want you to show that the sequence of value in this interval given by the iterative formula converge, then it converges to the root of equation in part A. So for this kind of question, generally what they want is very simple. You just need to try some way, okay, to start from the original equation in part A, which is this one, and you prove to get this equation, this iteration formula. All right, so this is what the question one. All right, you just need to prove it like this. You can also do it the other way around. That means you can start from this equation in part C and prove it back to part A. So it depends on which one you feel is easier for you or more convenient for you. All right. Okay, so for me, I will start from part A and prove until this equation. Okay, so my original equation in part A is x equals to 0.9, and then 2 minus cos x, and then sine x. Okay, then because of my final iteration formula here, I can see that I'm having the cos inverse here. Right, so that means I will try to make the cos x as the main object on the left. Then after that, I will want to take cos inverse. All right, so what can I do now is I will keep the 2 minus cos x as the main object first. Then I'm having x equals to x divided by 0.9 and sine x. So if I move it like this, then you can see very clearly that this is actually similar with what we have here. Okay, then again, I want to have cos x alone. So I will have this. So I think the answer is quite obvious already. So x is equals to cos inverse and then 2 minus x over 0.9 sine x. All right, so this is how we actually get the iteration formula that they want us to show. Okay, right, then part C. Then now we continue to part number D. Okay, so what we have for part D here. Okay, so part D, they want you to use the iteration formula to determine x correct to 2 decimal places, and your iteration should be in 4 decimal places. Okay, all right, so of course we need to have the initial value first. So what is the initial value that I want to use? Okay, so maybe from here, I can refer to my part number B. Okay, so for this part number B, right, I realized that my root will be between 0.5 to 0.7. And then you can start with any value like between 0.5 to 0.7. Okay, so for me, I might take the midpoint because I realized that the root 0, okay, fx equals to 0, the x should be very close to 0.6. So I'll start with 0.6, but you can start with either 0.5 or any value between 0.5 to 0.7. Right, so for me here, I want to start with 0.6. Okay, so what is my x number 2? So to get the x number 2, you need to substitute the x equals to 0.6 into the iterative formula in part number C. Okay, so which means you have to substitute inside the cos inverse and then 2 minus 0.6 divided by 0.9 and then sine 0.6. Okay, and then by using the calculator, you try to get the answer. All right, so now you can key in the formula here. Okay, so again, first of all, you have to ensure that your calculator is in the radian mode. Can you see the R here, the small r? All right, and then we are having the formula cos inverse, okay, with a 2 minus the fraction of what? The fraction of x. Okay, then divided by 0.9 sine x. Okay, so this is something that we have. So again, before you try to find out the answer, you double check and see whether your formula is correct or not. Okay, so once it is correct, then you can just start with calculate. All right, so when you press calculate, they will ask you what is the value of x that you want to input. So our first value will be 0.6. Therefore, you click in 0.6 and press equal sign. So from here, you'll get this value. So I will copy out the 4 decimal places, which is 6106, 0.6106. Then now I want to get my next iteration. All right, so for the next iteration again, you need to key in 0.6106 into your calculator. So again, don't do anything, just press a calculate in your calculator, calculate icon. Then again, they will ask you what's the value of x that you want to input. So I want to input my x2 now. So my x2 now is 6106, right? So I'll input 0.6106. Then you press equal sign again, and therefore you get this one, 6151. Okay, so your third value will be 0.6151. Okay, so your final answer they want is 2 decimal places, right? Okay, then you double check. For the x2 and also the x3 that you get in 2 decimal places, this one 2 decimal places will be 0.61. This one 2 decimal places will be 0.62, which is not consistent yet. Alright, so you have to continue until the 2 decimal answer is consistent. Alright, so that means I need to continue again for my x4. Okay, so to get the x4, you need to input this value in your calculator. Alright, so again, I press calculate again for 0.6151, and I press equal sign. So I will get 0.6170, so 0.6170. And then if I double check, this x3 and x4 are having the same value for 2 decimal places answer, which is 0.62. And then usually for me, I just want to double confirm. I will maybe get another one more iteration to confirm it. Alright, so for the next iteration, I will again press calculate, that input 0.6170. Then I press the equal sign, and I will get 0.6178. Okay, so which is quite confirmed already, because your x3, x4, and x5, you are having the same value for 2 decimal places, which is 0.62. Therefore, you can write a conclusion here. The root is actually equals to 0.62. Okay, so this is how we actually get the value for x in 2 decimal places, and you have to make sure that all your iteration, you are writing it out in 4 decimal places. Okay, so we come to the last question for this paper. Right, so question 11. With respect to the origin O, they give you the points A and B with the position vector. Alright, and they want you to show that OA and OB are equal to each other and use a scalar product to calculate the angle of AOB. Right, so when they mention about OA equals to OB, they are talking about the length for OA and also the length for OB. Okay, right, so to find the length for OA and OB, which is very straightforward. So to get the length of OA, you are getting the modulus of vector OA. So how to get the modulus for vector OA? So it is actually 2 square plus -1 square for the J plus 0 square for the K. Alright, so from here you should be able to get the value, which is a square root 5. And then you find out also the modulus for the vector OB, which is the length for vector OB. Alright, so to get the vector OB, you are having 0 square for the I, 1 square for the J, and also -2 square for the K. So you will also see that the value is the same, which is equals to square root 5. So therefore, you can write it out your conclusion where OA is equals to OB. Okay, so we have done the first part. And after that, they want you to use a scalar product to calculate the angle AOB in degrees. Alright, so the angle AOB. So to get the angle AOB, so maybe A is here. Let's say O is here. Okay, and B is here, let's say. Okay, so to find the angle AOB, by using the scalar product, right, you need to make sure that both vectors are going out from the O so that you can get the AOB. So when both vectors are going out from the O means that when you apply the scalar product, what you need to do is like OA multiply with OB. Okay, it is equals to the modulus of OA modulus of OB cos theta. So the theta here will be actually the angle AOB lah. Okay, all right. So how to get OA dot OB? So again, in the column vector form, the OA is 2, -1, and 0. OB will be 0, 1, and -2. And then the modulus of OA and also the modulus of OB, you already get it just now. Okay, then multiply the x component with x, y component with y, should be I component with I, j with j, and k with k for the scalar product. So on the left hand side, you'll get 2 multiplied with 0, you get a 0. 1, -1 multiplied with 1, you get a 1, and then plus 0 also, and it is equals to 5 cos theta. All right, so cos theta will be equals to -1/5. Okay, so for this question itself, generally they didn't tell you that they want you to calculate the acute angle. So the negative value here actually tells you that this theta is actually an obtuse angle. All right, so if you try to press cos inverse -1/5, you should be able to get an angle in the second quadrant, because in second quadrant only will the cos have the negative value. Right, so the theta here should be 101.5 degree. So they want you to keep your answer in the degree form. All right, so for degree form, the standard form will be 1 decimal places. Right, 1 decimal place. So the answer should be 101.5. Okay, so this is how we get the answer for part A. All right, so now let us continue to part B. Okay, so for part B, they now give you another information here saying that the midpoint of AB is N. All right, and then the P lies on the line through O and N is such that PA, the ratio of PA to OA is equal to √7 to 1. Then they want you to find the possible position vector of B, P. Okay, so this one maybe it looks like a bit more complicated, but before that we may just try to sort it out slowly lah. Alright, so the first of all is you actually can have a look that N is the midpoint of AB. Okay, so maybe you can try to find out the M first. So to find the M, I'm using the coordinate method. Alright, coordinate geometry coordinate method, okay, to find out the midpoint. Alright, so OA, you're having 2, -1 and 0, right? And then OB is 0, 1, and -2. So to get the M, so you take x plus x divided by 2, y plus y divided by 2, and then z plus z divided by 2. So very easily from here, you will get the coordinate of midpoint M, which is 1, 0, and -1. Okay, so it also tells you that the position vector for the M is equals to I, okay, plus 0j, then minus k. Or you can write it out as the column vector form 1, 0, -1. Okay, so this is what we have for the midpoint. Okay, so once you have the midpoint already, they tell you that P on the line through O and N. Okay, so now you're having O. O, again, the coordinate is 0, 0, 0. And M. M, just now you already get the value, which is 1, 0, and -1. Okay, so the point P is on this line. So P can be any part on the line. So P lies on this line. And then they tell you that PA, the length of PA, and also the length to OA is √7 to 1. So that means I don't know where's my A. So let's say my A is here. Okay, so they are saying they want you to prove that the length for PA to the ratio of the length of OA, this one is √7, this is 1, the ratio, right? Okay, so this is something that you want to prove and what the question about. Okay, so maybe for us, we will want to find out the position vector for P first. Okay, so to get the position vector for P, you need to have the vector equation of OM. Alright, so first I want to get the vector equation of OM so that I will know the position vector of P. Okay, so vector equation of OM. Alright, so vector equation is R equals to A plus TP, right? So the A should be the passing point and the P should be the direction. Okay, so passing point for this line got two, either the O or either the M. And of course, the O will be a is easier because all the value are 0 here. So that means your R is equals to 0, 0, 0 plus TP. So what is the direction of this line? So the direction will be OM. So where's the OM here? It will be 1, 0, and -1. Okay, so if you rewrite it again, then your vector equation will be something like this. Okay, so T and then 1, 0, and -1. Alright, then since the P lies on this vector equation, right? So the position vector of P is actually having the same equation for this vector equation. Okay, just that the T is substituted by some other value, such as maybe T equals to 1. So maybe your P is here. We don't know. Okay, but actually P means that there's a particular value T here. So maybe for me, I will just rewrite it again. So OP will be equals to the vector equation. But maybe I put it as other symbol like S, 0, and -S. I multiply inside the vector equation and I change the T become S, where S is a particular value belongs to the P one. Okay, to tell us where is the P along this line. Okay, all right, so this is our very first step. You need to try to get the vector equation of OM first. Then from the vector equation of OM, you get the position vector for P. All right, then next we want to focus on what they give us now. Since they tell us that PA and also OA, the length for PA and also the length of OA. Therefore, before I find the length for PA, I need to know the vector PA first. So PA means PO plus OA. Okay, so what is PO? PO will be -S, 0, and S. All right, then OA is actually 2, -1, and also 0. 2, -1, and 0. So when you add them together, the PA that you get should be 2 minus S, then -1, and also the S. This is your PA. Okay, all right. Then now we want to focus on the information here. All right, so I want to focus here now. Since PA, the ratio of PA to OA is equals to square root 7 to 1. All right, so I will write it up in the fraction form. Okay, so now since they said that PA to OA is equals to square root 7 over 1. So PA is actually the length or the modulus of vector PA. So the vector PA is here, right? So to get the modulus for vector PA, it will be 2 minus S squared plus -1 squared plus S squared divided by the length of OA. So the length of OA, you already get it just now, which is square root 5. And it is equals to square root 7 divided by 1. Okay, so all our terms here have the square root, right? So you can square everything to make all the square root disappear. Okay, and then when you want to make all the square root disappear already, then you can cross multiply to make the equation without the denominator. So square root 5, bring it up, and the 1, you bring it up and we take square for all the terms here. So all the square root will disappear. Okay, so eventually you will get something like this: 2 minus S squared plus -1 squared plus S squared. It is equals to 35. Okay, then of course you can try to expand this one. All right, and after that, if you try to group all the terms to one side, you should be able to get something like this. Okay, so we are having 2s squared. So minus 4s minus 30. Okay, then again, you can simplify it further. Then from here, of course, you can factorize it to get the value for the s. So you get the value for s, which is s equals to 5, and also s equals to -3. Okay, all right, so actually we are very close to our answer already lah. So s equals to 5 and s equals to -3, and they are asking for the position vector of p. So how can I get the position vector of p? Means that you just need to substitute this into the OP formula originally. Okay, so to get the OP, you can write it like this. So when s is equals to 5, all right, so what is your OP here? Your OP will become 5i minus 5k. This is your first answer for the OP, position vector of OP of the P. Okay, then after that, when s equals to -3, what is your OP here? So your OP will be equals to -3i plus 3k. So this is your second answer for the position vector of P. All right. Okay, so this one is to me, I think more steps involved lah. You need to create the vector equation first. All right, then get the position vector of P in terms of S. Then after that, by using the information that they give you, you try to solve and get the value for S. Then after that, you get a position vector for P. All right, so here we ended our paper. Okay, for this May June 2021 paper 3-2.